Hey everyone, Diane here. Welcome back. Today, we're going to be talking more about the pattern of multiplying by 10. More specifically, we're going to do some detective work about what happens to the place values of digits within a number when we multiply by a power of 10. Oh, but what is a power of 10? That is an amazing question. A power of 10 is the resulting quantity when 10 is multiplied by itself. So 100 is a power of 10 because we multiplied 10 times 10 to get 100. It uses two tens multiplicatively. Don't you just love that word? Multiplicatively. Anyway, what we really want to notice is the pattern that is created when we multiply by different powers of 10. You may be familiar with using base 10 blocks to look at place value. What I want you to do, if you can, is stand up where you are and pretend you're on a place value chart like I have right here. We are going to move like we are the digits. Ready for the first problem to explore? Let's go. Our first problem is 3 times 10. Think about what the product would be for that. Some of you may know it already. What is it? Right. 30. So we began in the ones place to represent the 3 units of 1. When we multiplied by 10, we got 3 units of 10, or 30. So the 3 digit shifted to the tens place. Can you think of why? Exactly right, because 30 is the same value as 3 tens. Now, let's move like we are this 3 digit, and we are going to show what happens when we multiply 3 times 10. So get up on your feet and hop with me. Or a nice sidestep, whatever works for you. So we started with a 3 in the ones place. When we multiplied 3 times 10, the digit shifted over to the tens place. So let's hop. Now, let's see what happens if we do that with 3 times 100. So slide back down to the ones place. And let's think about what is the product of 3 times 100. Can you share that with me? I heard someone say 300, and I heard someone else say 3 100s. Those are both great ways to share the product of 3 times 100. We know it's 300 because another way to say 3 times 100 is 3 groups of 100. So I have 100, 200, 300. So now the question is, how should we shift? Definitely needs to be to the hundreds, but how do we get there? Exactly. We shift 2 places to the left from the ones place, and that will get us to the hundreds place. So now, hop with me to the hundreds. Oh, that's interesting. So when we multiplied by 10, we shifted 1 place. And when we multiplied by 100, we shifted 2 places. I wonder how that could be. Maybe it has something to do with the powers of 10. Let's see if it holds true for another one. Let's find the product of 8 times 100. Remember, hop back down to the ones place and become the 8 digit. We know that 8 times 100 equals 800. So what happened to the 8 digit? Right, it shifted 2 places to the left. 1, 2. We moved 2 places again. Goodness, I feel like there must be a reason that we shifted 2 times when we multiplied by 100. What do you know about 100? I heard someone say something really interesting. They said, one thing that I know is that 10 times 10 equals 100. That could have something to do with it. Let's try something and see what happens. So I know 5 times 100 equals 500. But what if I said, what is 5 times 10 times 10? Did you say and do 5 times 10 equals 50, and then 50 times 10 equals 500? Good thinking. In both of these examples, we shifted 2 times. I think we found a link between tens and digit shifting. But I wonder what would happen if we multiplied a 2-digit number. Let's try 15 times 100. See what happens to the digits. Yeah, I'm thinking about it. It's a little tricky, but I got 1,500. Let's do some shifting and see if the same thing happened. So, how are the digits shifting? Let's start at looking at it piece by piece. So the 5-digit started off in the ones place. And with our answer of 1,500, where did it end up? Will you whisper it to me? Ah, yes, it is in the hundreds place now. But what about the 1 that started in the tens place? Where did it end up? For sure, it ended up in the thousands place. So let's hop now and see what happens. So I'm starting as the 1, and I'm going to go to the thousands. So 1, 2. So the digits shifted 2 places to the left again. Isn't it interesting that even with the larger numbers, the digit shifting was still true? With powers of 10 and using our wonderful minds, we have seen a pattern to make it easier to solve different problems that have us multiplying by a power of 10. The number of tens multiplied together helps us know how many times a digit will shift. So when we multiplied a number by 100, the digit shifted 2 times because 10 times 10 equals 100. 2 tens multiplied together. I wonder what would happen if we multiplied by 1,000. Thanks for being with me. See y'all.